Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in our previous sessions we have covered and discussed the issue of autocorrelation, and there you have learned how to detect and find the issue of autocorrelation using the Durbin-Watson test. But keep in mind, dear students, this Durbin-Watson test is just not appropriate in most of the situations. In most of the cases, we are not using the Durbin-Watson test, and there is some alternative method, inshallah, I'm just teaching here, okay? Okay, first I'm just quickly reviewing what is the autocorrelation. The autocorrelation is just a situation where the error term is correlated with itself. And technically, you can say the covariance of the error term at time t and error time t minus 1 should be 0. It's been according to the classical linear regression model assumption, there should be no autocorrelation for the model to be blue, right? For the ordinary least square method to be blue. Okay, now dear students, I'm just teaching you why the Durbin-Watson test is not appropriate and we should use one another test, and that is the Bruce-Godfrey test, inshallah. Okay, learn. Okay, this is the error term and this is the ut minus 1, and here we are just checking the first order autocorrelation. So this is the ut, and ut minus 1 is just the first order autocorrelation. We have the second order autocorrelation when it is ut minus 2. If you're just comparing and checking whether this error is just not correlated with the error of 2 years before, that is just called the second order autocorrelation. So now we are just interested for the first order autocorrelation. Okay, for this purpose, for detecting the issue of autocorrelation resistance in the model to check whether it's just correlated or not, first I'm just using the Durbin-Watson test, and then I'm justifying that the Durbin-Watson test is just not appropriate, why and where it is not appropriate, and when you should use the alternative method, which is the Bruce-Godfrey test. Okay, so now I'm just using the Stera, so you should just open your Stera file. Okay, here in the Stera, you should open your file. I'm just importing my file from Excel, so my file is just stored here in Excel. I have a Stera file. Okay, just click on this. Okay, students. Okay, this is not relevant, I'm just dropping it. Okay, dear students, as you know, this is the time series data. So for the starter, I should just tell the starter that what is my time variable. So the time variable, simply this is just the year. Okay, the time variable just set, and then you should run the regression, type reg, and then the dependent variable, this is GDP, and the independent variables. So first you should put your dependent variable. Okay, the if statistic value, this is just significant, the model is significant over all the students. Now just select for the, just see for the individual significance, you can say all these individual variables are also significant. So you can say all the government exports investment, they are just positively and significantly affecting the GDP. But this output is just not reliable, right? You cannot use it in regression analysis or in your research unless you are sure of what the autocorrelation. So for checking the autocorrelation, simply we are using the Durbin-Watson test, and previously I've just taught you both method in Excel and also in Stera. Once again, I'm just repeating simply in Stera, so you should just write DW and state, right? This is the Durbin-Watson state. This is a value 0.337, and this function or formula is just giving you the same value versus if you just do it manually. Okay, now the problem here is, now from this value you should just decide whether we are having the autocorrelation issue or not. So we have a special table, the significance Durbin-Watson table. Just go into that table, but keep in mind how to check and where to check this value. First, you should know what is the number of observations. So the number of observations, we have 55, right? In the number of independent variables, we have 3. So these informations, they are just really important. Look, dear students, okay, the number of observations and the number of independent variables, and also we are checking for the significance level of 0.05. Now, what is the Durbin-Watson test? We simply found out this is the value, dear students. Look, this is simply the value 0.337. 0.337. Okay, now just check for this 0.337, you should just find out what is the lower value and the upper value. In these values, I've just simply taken from the table. Just go into the table, look in the table, just this is the table. In this table we have, this is the Durbin lower and Durbin upper for 1K, and this is for 2K and for 3K. So for 3K, just look here for the 55 number of observations. We have the lower, this is 1.452 and 1.681, right? So 1.452, right, here is 2 and 1.681. Okay, dear students. Okay, now Once you have the Durban lower and Durban upper value, then you can just find out all these values. Simply let me just show you how to find out. Okay, the Durban lower value, this is simply the Durban lower value and the Durban upper value. And then these two values, once you find out these values, then it's simple to find out the 4 minus du. It means simply from 4 you should subtract the du, Durban upper value, and then equal sign from 4 simply you should minus dl, the Durban lower value, right? Okay, now we have the decision criteria. This decision criteria is just based on this line. Just look at it, students. In the Durbin-Watson test, we have 3 main values. The zero is just indicating the perfect positive correlations. In the 4 is just indicating the perfect negative correlation, right? In the 2 mean there is no correlation at all, right? So, dear students, according to the Durbin-Watson test criteria, if the Durbin-Watson's value just lies in this range, in particular, then you can say there is positive autocorrelation, right? And if the Durbin-Watson value just lie here in this range, then you can say, dear students, there is negative autocorrelation distance, right? Okay, and if the Durbin-Watson value just lies here, dear students, in this range, then you can say there is no autocorrelation. So you can say just here, look and see, if the Durbin-Watson value is just lower from the DL, right, it is just here, then you can say there is positive correlation. If the Durbin-Watson value is just greater than 4 minus DL, it's mean in this range, then you can say there is negative autocorrelation. And if it is just here in this, so if the Durbin-Watson is just in between the 4 minus du and du value here, okay, so you can say there is no autocorrelation. But the problem here, dear students, is if the Durbin-Watson value just lies here in this range, right, or it just lies here in this range, in that situation, you can say the test is just inconclusive. The result is what? Inconclusive. It means the Durbin-Watson test is just not telling you, right, whether we have autocorrelation or not autocorrelation in these two areas. So that's why the Durbin-Watson test is just not appropriate if the values of the Durbin-Watson just lie here. For that situations, we are just using the Bruce-Godfrey distributions, okay? Okay, now, according to this example, the Durbin-Watson value, we found out 0.337. Now, how we can decide, okay, the decision is here, just simply compare this value with the critical area. So this 0.337 is just lower from the DL value, and the DL value is just here. So we can say this is the region, this is the area where we have the positive autocorrelation. So from here you have just learned that according to the Stera output here, dear students, we have the positive autocorrelation. So we have the issue of the autocorrelation, dear students. But the point I'm just trying to explain, dear students, that Durbin-Watson is just not appropriate here. Okay, what if your value just lies here in these two range? In that situation, you should not use the Durbin-Watson test. And for that, we are having one more test, and that is just the Bruce-Godfrey test, okay? The formula for the Bruce-Godfrey test is just you should type E straight and just you should type B and then God, free and comma, and then you should just type lake, and in the parentheses you just type 1. If you are just interested for one first order autocorrelation, then you should like 1, and if you are just interested for the second order correlation or any higher order autocorrelation, then you just use 2, 3, 4, 5. But we are just interested for 1. Just press enter. This is the output of the Bruce-Godfrey test output. This is what is called the Bruce-Godfrey test. Okay. Now the alternate null hypothesis, there is no serial correlation. The serial correlation autocorrelation is same. Serial is just it's been taken from the series, because in the time series usually the autocorrelation is common, right? So that's why the serial correlation and autocorrelation means same. So the null hypothesis simply is there is no serial correlation, dear students. Okay. So what could be the alternative hypothesis? Yes, there is autocorrelation or serial correlation. So if the p-value is just less than 0.05, then we are rejecting the null hypothesis. And when you reject the null hypothesis, it means you are claiming that yes, there is autocorrelation. So 0.000 is just meaning that there is positive autocorrelation. And the favorable value, that this value should not be less than 0.05, right? So if it is greater than 0.05, then we are just claiming there is no autocorrelation. So now here we have autocorrelation. Okay, this is just I have taught you that the Durbin-Watson test is not appropriate sometime, and we should use the Bruce-Godfrey test. Okay. Okay. Now For solution of the autocorrelation, I have mentioned several methods. Once again, I'm just repeating here just to learn. Okay, you can use many methods, right? You can use simply the Nuvey-based method. The Nuvey-based method, just you should type the Nuvey, N-E-W-E-Y, and just your dependent variable. This is our dependent variable. And just check your independent variables. And finally, you just type leg1. This is one method. Yes, this is the Nuvey. This is the Nuvey based method. Okay, when you run this regression, if you find out dear students that there is autocorrelation, then if you just run this regression and use this output for your interpretation or for your research analysis simply, right? So this is just a method that is just removing the autocorrelation, or you can say this is a method just correcting for the autocorrelation, standardizing the standard error and correcting for autocorrelation. So this is one method. And also, if you remember, I have used the first differencing method, right? And also we have used the legged dependent method. Okay, first difference method, just you should find out the first difference of GDP, government expenses, exports, investments. How to find out the first difference? It means the today's year's value should be just subtracted from the yesterday's value. What is the difference between each two years, right? Simply this I have explained if you remember. So if you just find out the first difference, you can just generate. You can use the command of the gen, and I'm just using another name. I'm just renaming this using another name. So I'm just telling to dgdp, right? And this should be equal to d.gdp. Okay, d.gdp. This is just command, just creating for you a new variable by the name of the first difference dgdp, right? So I have just generated for the dependent variable in similar way you just generate for the government expenses. So d government expenses, this is equal to simply d dot government expenses. I have just generated the first difference for the government expenses, and similarly you should just generate for the exports. So d export, right? And this should equal, okay, this is whatever name you just choose here, you can just choose it, no problem. And here just d export. Okay, we have generated for the export, and also you should generate for d investment, right? So gen and d investment and equals d dot investment. Okay, so I've generated all of these values, the first difference of all these values, and now you just can run the regression. Just run the regression and take these new variables. These are dependent, and all these three, these are independent variables. Simply, now this regression is appropriate response. This output is just appropriate. You can just use it. Okay, you can just use the first order, the first differencing method, or you can just use the Nuvey-based method. Both of these methods are just correct response. And lastly, you can just use the lag dependent variable method. It means you just find out the lag value of the GDP, right? Incorporate the GDP value into your independent variable, then that output is also acceptable, right? Okay, the method for that is just generate the lag value. So you can, I'm just typing the GDP, simply GDP, right? GDP lag. Okay, I call it just GDP lag, right? And this should be equal to the L.GDP. The L.GDP is just generating the lag value for your distance. Okay, now this just incorporate this lag dependent variable to your independent variable. So run the same normal regression. So reg, and this is the GDP or dependent variable, and this is our independent variable. And now among the independent variable, just include the GDP lag value, right? Press enter. This output is also acceptable to your students, and here you can say the autocorrelation issue just removed, right? So you can just interpret these values for your regression output. Only the lag GDP we have here, this variable is just observing the error of autocorrelation, and for that your output is just reliable and trusted results. Hopefully the idea is clear. Here you have just learned the results where the Durbin-Watson test is not appropriate, and instead we should use the Bruce-Cartwright test, dear students. Okay, and also once again you have learned how to remove the error of autocorrelation. Assalamu alaikum wa rahmatullahi wa barakatuh.